our topic for this lecture is median. What is median? Let's say we have n number of data. When the value of that data, that variable, value of the variable, we call them variables. If we have marks of students for certain class, then we say this is a variable. Marks obtained by A is 50, marks obtained by B is 52. So these are variables, 50, 52, 60, 70 and so on. So the value of the variable which is in the middle of the distribution of this data, that is the value which divides the data into two equal halves, is the median. What is the meaning of this? Let's say I say the median of the marks obtained by the student in class 10th is 65. So by this value, you know that 50% of students have scored higher than 65 and 50% of students have scored less than 65. So this is median. How we find median? See, let's say we have data 6, 8, 4, 2, 1, 9, 10. Okay. First of all, arrange these data in ascending or descending order. So this will be 1, 2, 4, 1, 2, 4, 6, 8 and 10. Okay. Let's say we had another number 11. So this is 11. Now the number, the value of the variable which is in the middle of this distribution, it is 6. So 6 is the median. That is, we know that half of the data is above 6 and half of the data is below 6. This is when we had odd number of observations. This is odd, 1, 2, 3, 4, 5, 6, 7. We have odd number of observations. So finding median is very easy. But what if we have even number of data? For example, 1, 2, 4, 6, 8, 10. So here we have 1, 2, 3, 4, 5, 6. What we do, this is even number of observations. So what we do, we take the middle two values, this and this. We have 2 here and 2 here. We add them and divide by 2. We take the average of the two. So this will be 5. So median here is 5. So this is median, 5. Half of the data is above 5 and half of the data is below 5. This is the concept of median. So this is a positional average. This is the average which is in the middle of the whole distribution. Okay, and let's see one more thing here. We have this data. Let's do it from here. Our median is this. What is the arithmetic mean? Let's find the arithmetic mean here. This is 2 plus 1, 3, 4, 7. So this is 42 by 7. Mean is also 6. See, mean is 6, median 6. That is, the data is symmetrically distributed. If you plot a graph, it will be like this. In the middle, you'll have mean and median. So this is a symmetrical data, but this may change. How? Let's say this was 20. Instead of 11, we write it 20. The median still will be 6. What will be the arithmetic mean of this figure? This is 42 minus 1, that is 31 plus 20, 51. 51 by 7. So this will be 7 point something XYZ. Okay. Now median is 6, mean is 7. So if the distribution is skewed towards this side, we have this as this, our median will be here only, but mean will shift to the right. So mean and median may or may not coincide. This is mean and median. Now what is the median? We just saw for simple data, but what if we have discrete frequency distribution? What will be the, how to find the median of a discrete frequency distribution? Let's see how. Let's say we have x equal to 2, 4, 6, 8, and the frequency is 10, 5, 20, 10. Now, what will be the median for this discrete frequency distribution? What we do? Step 1. Find n by 2. What is n? N is addition of this. So this is 10 plus 5, 15, 15, 20, 35, this is 45. So this is n by 2 is 22.5. We have found n by 2. Now what we do? We take cumulative frequency of this. Cumulative frequency. What is it? 10. Then this is 10 plus 5, 15. This is 15 plus 20, 35. And this is 35 plus 10, 45. This is cumulative frequency, less than cumulative frequency. So n by 2 is this. The cumulative frequency just greater than n by 2. So greater than 22.5 is 35. The value corresponding to this, that is 6, is the median. Clear? What we do? We have x, we have f, we find n by 2. We take the cumulative frequency of this data. What is cumulative frequency? This is less than cumulative frequency. This is how we how we calculate cumulative frequency. 10 is 10. Here we keep on adding. Less than cumulative frequency means that if this is 15, that is 15%, 15 data is below this value. So this is cumulative frequency for less than. We can also find cumulative frequency for greater than. How? This will be 45 here. That is all data above this value. Then 45 minus 10, that is 35. Then 35 minus 5, that 30. 30 minus 20, that is 10. So this is greater than cumulative frequency, greater than values. But in this case, we have to find this only. So we have found n by 2. The value of cumulative frequency just greater than n by 2. It's 22.5. This is less than 22.5. So greater than 22.5 is 35. And the value of x corresponding to this is median. So 6 is the median. This is discrete frequency distribution. What if this was continuous? That is group data. In case of group data, how we find the median? Let's see. In case of group data, we find median by a formula, that is, it's L plus H by F by N by 2 minus C. What is L? It is the lower limit of the model class, median class. What is median class? What is median class? Median class is the class with highest frequency. What is H? It is the class interval. What is F? It is the frequency of the median class. What is N? You know, adding all the frequencies, F1 plus F2 and all. And what is C? C is the frequency of the class preceding the median class. That is, we have median class, then just above it, what is the frequency? That is C. So we'll do an example to understand it. Let's see. Let's say this is the 10 to 20. This is a class. Then 20 to 30, 30 to 40, and 40 to 50. And frequency is, let's say, 5, 10, 5, 2. Okay. So obviously this is the class with highest frequency. So this is our median class. Okay. Then how to find median? What is n? 15 plus 20, this is 22. So what we do? L, the lower limit of median class, that is 20, plus H, H is 10, by F, median class, frequency of median class, this is 10, N by 2, N is 22, so this is 11, minus C. So frequency just below this median class, preceding this median class. So this is 5. This is 20 plus, this is 1, 11 minus 5 is 6, that is 26. So the median is 26 here. Okay.